So now we know the impact of changes in pricing on quantity. We know that if we increase the price, our quantity will come down. And if we try to decrease the price, our quantity will go up. And majorly, we are talking about elastic products. Yeah, because that will give us significant impact, yeah, to support this demand rule. Because this is our demand rule, generally speaking. And that is how elastic products behave. Because generally speaking, all products are expected to be elastic, just that the degree of elasticity is what makes us categorize them into these 5 different categories. Yeah, generally we expect that people reduce quantity when price is high. Right. So how do we now know at what point do we price our products? The solution or the answer is that we have to choose. Let me write it. We must choose the price and quantity combination that will give the highest profit. So revenue is 20, is 38, is 51, is 60. So we're asking that, should we sell at price of 20 or price of 19 or price of 17 or price of 15 or 13? We don't know, because at those different prices, we'll be able to sell different quantities. If we sell at $20, we're only going to be able to sell 1 unit. So if we assume that our variable cost, or what you call marginal cost, is $8, for an example, it means that I can calculate our profit for each scenario. For scenario 1, what will be our profit? Revenue is 20, cost is 8. We have $12, right? For scenario 2, which means we are charging $19, but we'll be able to sell 2 quantity, and each quantity will cost us a cost of $8. So that means that our total revenue of 38 minus total cost of 2 times 8, which is 16. So 38 minus 16, that's 12. Not 22, sorry. So this will give us profit of 22. The third scenario means that 3 units, and we are making revenue at $17 to have total revenue of 51. So 51 minus 3 times 8, that's 51 minus 24. And that will give us 27. For the fourth one, the total revenue is 60 minus 4 units times 8, that's 60 minus 32, and that's 28. Yeah. Then the last one, total revenue is 65 minus 5 times 8, that's 40, and that goes to 25. So the question is, looking at this scenario, 5 scenarios, 5 different prices that we can charge, what price should we be charging? Since we said we should be charging at a price that maximizes our profit, what price will maximize our profit here? So we can see that the highest profit is at the price of 15. And that is the only place we're able to make $28 profit. So which means if we charge a price of 15, we will sell 4 units, and that will maximize our profit for us. But this is a manual way of doing it, because we have to calculate everything, the profit one after the other, to be able to pick the highest profit. But there is other way of doing it, and that is through the graph. Yeah. Because generally speaking, when you draw the demand curve, so you have your dollar here, you have your quantity here. So we expect the marginal cost, which is variable cost, $8 per unit, to be constant. But what has happened to the marginal revenue? Let's check. So we're using the graph. We have to plot marginal revenue and the marginal cost. So what is marginal revenue? We said marginal revenue is the extra revenue you make on extra units. So which means for the first one, the marginal revenue is 20 because that's the first unit. But by the time we produce the second one, which is 2 units, we are making total revenue of 38. So the marginal revenue will be 38 minus 20. So we are making extra 18 revenue on extra unit. We'll move to the next one, which means we extra units to make it 3. How much extra revenue have we made? 51 minus 38. What is that? I think that's 13. Yeah. Then an extra unit again, we have 9. An extra unit again, we have marginal revenue of 5. What has happened to marginal revenue? As your quantity is increasing, your price definitely must be decreasing. That is why your quantity is increasing. Yeah. And what is happening to marginal revenue is also coming down, because that's what you expect, because your pricing is going down. That is why you are able to get more quantity. So if you put your marginal revenue here, you expect it to be like this because it's coming down. So this is your marginal cost line, and this is your marginal revenue line. Ladies and gentlemen, this is the point where your marginal revenue is equals to marginal cost. And any quantity you have here is your maximum quantity that maximizes your profit for you. So any quantity you have here where the 2 lines intercept is where you will be maximizing your profit. So by rule, you are expected to maximize profit when marginal cost is equals to marginal revenue. And you can see it. If you go on the right, if you go towards the right, this direction, from this point, if you go to this place, what happened? You will see that your marginal cost line is covering up your marginal revenue line. So which means from here, cost is greater than the extra revenue you are getting. Remember that it only makes sense for you to produce extra units if the extra revenue is more than the extra cost. If the extra units will give you extra revenue that is more than that extra cost of producing that extra unit, that's when it's profitable. Marginal cost is the extra cost. Marginal revenue is the extra revenue. So any point beyond this point to the right, your cost is more than the revenue. So you can't produce more quantity. Any quantity more than this quantity is no, because you will make loss. But if you come this way, all the way from here to here, your marginal revenue is greater than your marginal cost. So keep producing. up to this point, because every unit you produce will give you extra profit. So if you accumulate everything together, you will make a lot of profit. So if you look at this now, if you produce one quantity, you're going to be somewhere here. Your revenue is still covering your cost. So don't stop there. Keep going. The second one, the third one, the fourth one, up to this one. Let's say this is the number 4. So which means you are able to produce 4 because that you have maximized your profit. If you produce the 5th one, you might be here. That's what we're saying. And we can actually plot this thing on the graph, but we don't have that time to put it. I will actually show you straight away on the graph, well scaled, and let's see what it's going to look like. Yeah. Okay, so one thing that you need to know is that profit is maximized when marginal cost is equals to marginal revenue. Yeah. So profit is maximized profit at quantity. Very important. When the marginal cost is equals to your marginal revenue. So don't produce more than that and don't produce less than that. Try and produce. But even if you have to produce a different figure, you have to produce less figure and not more figure. Because less figure will still be staying in the blue zone. But more figure will go to a red zone where you'll be making loss. So the last thing I want to just touch on quickly is what we've done before, but I just want to show you how you can also take it to a further level, which is using the demand curve, that demand equation, the demand function, to get your marginal quantity. Yeah, which is your best quantity when your marginal revenue is equals to your marginal cost. Remember, we've done manual method, we've done graph. Now we want to use the demand function, which is the most important actually, and most examinable. It's very unlikely they will ask you to plot graph. Maybe they will have plotted the graph or they have plotted it, and all you need to do is to get your quantity from the interception point. That's where they can test that. The manual one, that's for the BT on MA. They won't ask you to do that. The popular one is you using this demand function to get your optimal point. How to use demand function. And that's the last thing we're going to do. So let's just look at this. If price and quantity is this. So you have price 1, 7, and 8, and quantity at 160. So we already have the two scenarios. Remember, you always have those two scenarios. Yeah. Even if you have more than that, just pick 2 points like this to do your equation. Remember the first thing I told you? I said you must calculate M. Yeah, which is change in price or change in quantity. So in this scenario, that's 8 minus 7 over 60 minus 100. And what is that? That's minus 1 over 40. And that will be equals to 0.025. So that's minus 0.025. So which means our price equals to C minus 0.025 quantity, demand equation. Then the next thing is we need to calculate our C. And we said for C, we can just use any of this scenario, whether scenario 1 or scenario 2. This is P, this is Q. So let's choose scenario 1. P is 7, right? And Q is 100. So that means 7 equals to C. 0.025 times 100, that's 2.5. Yes. So C equals to 7 plus 2.5, and that's equals to 9.5. So that's our C. Then we can plug it here. So we have our demand function already. So our demand function is that P equals to 9.5 minus 0.025 Q. So we have our demand function. What is next? Remember what we want to get. We want to get our optimal pricing. Yeah, before we can get that, our marginal revenue must be equals to our marginal cost. Remember, this is the rule. So let's say marginal cost equals to 5. Yeah. Let me write it there so that you don't start looking for how did we calculate this. Assume that marginal cost is equals to 5. In that case, what's our equation for marginal revenue? If this is the demand equation, remember, the marginal revenue, like I told you earlier, is just to multiply this side by 2. And it becomes your marginal revenue function. So for marginal revenue function, marginal revenue will be equals to 9.5 minus 0.025 times 2, then Q. And that will become 9.5 minus 0.05 Q. Make sense? So now that we know that this is our marginal revenue, to get the quantity that we should be selling to maximize profit, this must be equals to our marginal cost. So marginal revenue must be equals to marginal cost. And we have assumed that marginal cost is 5. So which means 9.5 minus 0.05 Q must be equals to 5. So which means that 9.5 minus 5 equals to 0.05 Q. And Q will equals to 4.5 divided by 0.05. And what's that? Giving us 4.5 divided by 0.05. That is giving 90 on my calculator. What is it giving you? What do you have? Do you have 90?
I have 90 as well.
Me too.
Fantastic. So that is the unit that we need to produce. But remember, this topic is about pricing. The question is, what price should we charge to be able to sell these 90 units? So it's the same equation we're going to use, right? So since we know that our demand function says that P equals to C minus 0.025 Q, the price that we want to calculate, we know our C already. We know our Q is 90. So what do we get as C? 9.5. So that means 9.5 minus 0.025 times 90. And that's 9.5 minus and times. That's 2.25. And if you deduct that from 9.5, that gives $7.25. So that is the price that we should be charging. Because that's the price that will give us maximum profit. And at that point, we expect our marginal cost to be equal to our marginal revenue. So you can see how you have used demand function to determine the appropriate pricing. Any question? And I think That is everything on pricing decision.